Okay, this is time for ARDL test. Now we are going to do that one. In the previous video, we did DOLS and full panel. Now let's now look at this. That's ARDL co-integration analysis. So we just have to use the same set of files to do it, as time is of essence in this. Yeah, so the ARDL is just like the OLS and the DOLS. So for that reason, we are not going to bother our head too much on using different edition. Also, with this one, you can see that the ARDL input box also disable the time and the variable groups. So now let's go. Let's use the same thing that we used before. Now let's use meal as our dependent variable, and then now let's use ing1, ing2, ing3. As before, everything here is just separated by separated here by just the comma, no space. So we move on. So we move on from there. The time interval and the variable groups were disabled. So we move on to the name of the data set. As usual, we still type the same name, SUMTAS. So we now click use Excel. I wonder why this one is asking me to use Excel too. Okay, but that is it, and that is the results now displayed. Yeah, as usual, this is the data use. This is the output is here. Data use is even appearing twice. Okay, the output is here. We have the ADL co-integration test results. The engine values is this. The trace statistics is this. The critical values are all listed here. This is one good thing about ARDL co-integration. So it gives you what other regressions will not be able to give you. You're like this critical values, trace statistics, and engine values, just like that. And the dependent variable as before is meal. Model is OLS. Then the method is least square, and all the other junk, this thing that we have here is there. Then the R squared is this, just like before. They have AIC, AKIK, whatever. The log likelihood, and so on and so forth. Yeah, so others, then after then you now have the display of the coefficients. For the constant and then for each of the other the independent variables. And then you have the t statistics and you have the p-value. And here the constant is significant, but the three independent variables were not significant. Then omnibus is this. The Watson is 1.8. Jackie Berra and so on and so forth are all there. And these are notes. And then after the notes, we were also told that the condition number is large. Therefore, this might indicate that there are strong multicollinearity or other numerical problems. Yeah, remember that the ones that we use the same figure for, which with what do you call it now? The one that we use the same figure for with VIF showed very large distance for that. So that's it. So then the analyses are also in ARDL reg. So now let's look at it. Let's look at it from the C value stats, and let's see whether it is there or not. ARDL. It's supposed to, okay, maybe let me close it and open it because it's not showing me that. Let me open it again. Yeah, that's it there. That's it there. So we click it open. Yeah, and it's showing us what the screen just showed us. Just like that. This is much more refined. So that's it. That's the ARL co-integration. A very robust test indeed. Okay, so now let's go to the next one and see what it can offer us. Yeah. The next one, let's see what it can offer us. The next one is logistic regression. In logistic regression, we have two types. We have the ordinal logistic regression and we have the LOGIT regression. Now, the difference between the two is that logistic regression, which is the LOGIT, uses, that is the dependent variable uses only binary 1 and 0 as its own figures. But with ordinal logistic regression, the dependent variable uses ordinal, that is words like compliance, non-compliance, agree, disagree, and so on and so forth. So we are going to first of all look at the LOGIT first. The LOGIT, we'll call it up. The LOGIT is, we are going to use the data of a telecom subscriber to look at it. So now the outcome variable here, which is the dependent variable, is called SPD. And then the independent or predictor variables here, well, I think age is there. Then gender as gen. Then we have DTS, that is data service. And we have wireless, WLS. And that we have CRF. I think there's still another one. Age, gender, data service. Okay, then we also have CLS. So these are the one we are going to use for this. And then the name, you can see that I also separated them with only comma, no space. That's for the dependent variable. And for the independent variable. The dependent variable is always alone, except in some other cases which we are going to encounter later. Now, this is supposed to be the file name, but I have to clean it to get the one that I know that will save the file with. The name is telecom, and then we process. I believe good. Now, because it is there, so first of all, it's not giving us the plot first. It's going to show us the plot. The second plot, this one is the line graph. Now this one is the density plot. And this is the horizontal bar chart. The first one was the vertical bar chart. And then that's it. Now let us now look at the figures that it produced. Okay. Okay, this is where it starts. It started with this, and then I think it has a total of 60 observations. And those 60 observations so variance inflation factor here, age had none of them is too high anyway. None of them is so high, so we don't see the multicolorality problem here. But let's see. Now, the optimization terminated successfully, trying to tell us that it was a successful analysis. Now, the dependent variable as before is SPD. The model is LOGIT, and then the method used MLE, and the date and all whatnot. Then the number of observations is 40, number of residuals is 53. A DF model, that is degree of freedom for the model, is 6, and then pseudo R squared 0.115. Then log likelihood is minus 11. LL mole is minus 40.381. LLRP value is 0. Which is not significant. Now let us look at other this thing now. Look at the what do you call it now? The dependent variables. You can see the predictor variables. Look at it there. Their coefficients, starting from the constants to age to CLS, their coefficients, the standard error, the Z. This one uses Z, not T statistics. This time around it uses Z statistics, and then the p-value. The p-value here in this particular one, I think the only one that is significant. The only one that is significant here is. No, I'm not even sure that it is significant. It's not even significant. Okay, none is significant in this particular case. None is significant. And then you also have the lower bound and upper bound. And then the likelihood ratio test, LRT, is 0.1002 and so on and so forth. Then, this is where it is interesting. This is world tests. The world test normally replaces the t-tests for this type of analysis, and the world test uses chi-square as that. So with this one, we look at the chi-square and the probability of none of them is also significant as before, and that is how it is. Now the logistic test results have been saved to C, values as to LOGIT results and text, and then the graphical plots are also saved as LOGIT with whatever other name that is there. Now let us look at whether we can find this LOGIT something now. Okay, now that's it. This is the LOGIT result. The LOGIT result. Now let's click on it and then open it. Yeah, that's it. That's the LOGIT result. That's the LOGIT result. This is the one that you can print. And then let's close it and then open the plots. Now, the H plot, the horizontal bar chart. That's the horizontal bar chart. Yeah, so then let's just open the density bar chart and then we're done for that. That is density plot, the density plot. Okay, so that is how this one pans out. This is yeah, that's it. That is for logistics regression. That's number one. Now we'll now go on to the second LOGIT regression, which is the Ordinal Logistic Regression. We click it open and then wait for the form. Yeah, this is the form. Now with this one, I've explained to you what ordinal means, but now let us look at it. We will now see exactly the difference between this and that one by the time we are done. Now, let me be sure, because this can be very tricky. If I don't get the complete distance, I mean the actual data, to give me error. So now let me be sure. This is saved in a file named vehicle. Where is the vehicle? Telecom. Where is the vehicle? Vehicle. Where are you? Aha, good. That's it. Now I have to click it so that I will open it so that I will know exactly what I'm dealing with. So let me see exactly. Okay. Now, yeah, condition is going to be our. Now let's see. This is the inside the file of the vehicle, which we are going to use for the ordinal logistics. Now, condition is going to be our dependent variable. Now, this condition is trying to describe the condition of a vehicle, which is as a result of the usage, the road condition, and other parameters. So now, this one, you have conditions like usable, excellent, good, bad. 4 conditions. Now let us see how this accident means the number of times it has had an accident. Then the age is the age of the driver. MTC is the frequency of maintenance. How frequent is the maintenance? And then usage is the frequency of usage. And then engine size, according to the engine capacity, you normally have the liters, engine capacity in liters, and that's cylinder. Then that's the engine size. Then the road con is the road condition, and then the driver. The driver is maybe according to how experienced or not experienced. I think we have only just 3 values here: 1, 2, 3. So 3 will being the highest, 1 being the lowest. Road condition also has, I think, up to 3. 1 being a good road, then 2 we have fair road, and then 3 is a bad road. So now we are going to use it now to look at what we have here. So now we are going to use it. First of all, the outcome variable here that we saw is called condition. So we have to type it, condition. Then after the condition, we move on to the predictor variables. Now the predictor variables here are age, comma, you have MTC, that's maintenance, comma. You also have accident, comma. You have road con, comma. What other one? And driver, comma. I think there is still another one. Maintenance, road con, driver. Let me see. Okay. Okay. Accident, maintenance, usage. Then engine size is the other one. Usage and engine size. It is not a must that you must use all the this thing. Not the must that you must use all the variables. You can use just the one that you want to use out of it. But let me just use all of them. So I think what we had, we have usage. Usage have not been used here, so usage. And I think the last one is engine size. Engine size. Okay. So having done that, we now place the cursor at the dataset file name, and the dataset file name is not odd log, it is vehicle. That is what was used in saving that. So having done that, now let us now what? Now let us now click process data. Yeah, so I started processing with this weird looking bar chart. Then another weird looking line graph, but all these are not necessary. Then another weird looking scatter plot, which we may not use. Yeah, so having finished with this, now let us now go to where, okay, let's minimize this. Now this is our result now. This is our result. Now, this is the result of the Ordinal Logistic Regression. Good. So it will start just like the other ones with the VSP logo, and then we'll do the descriptives, statistics, and then the variance inflation factor. This one has some multi-collinearity issue with let's say usage. Usage is 20, which means multi-collinearity of 20 is high, and age is a little bit high also. So, but then let's just go ahead, and then we have the correlation matrix, just like as we do in others. Then say maximum over operation has been exceeded. Well, now those ones are the jargons of this. So then now this is the MN LOGIT regression result. The dependent variable is condition, as it is here. Model is MN LOGIT. The method is MLE, and then all other information that relates to time and all this. And then you come to the other side, you have the number of observations is 841. Oh my God! So it's a very big data. A big data, 841. Number of residuals is 817. Degree of freedom of model is 21. And then pseudo R squared is 0.5682. Okay, this is okay. Then log likelihood is this. LL null is this, and then LLRP value is I think this is kind of significant somehow, but let's see. Let's look at others. Okay, now this is one thing about this ordinal logistic regression. Yeah, it tries as much as possible, first of all, to look at the coefficients, then the same way that others look at it, but it uses the z instead of the t-test this time around. Now you can see that the constant is not significant, but accident maintenance and age, accident maintenance are significant. Usage is not significant. Then engine size is also significant. Road condition is also significant, but driver is not significant. That is about that. Now, let us now look at the down part. Now, if you look at this one now, it's trying to compare condition, that is trying to relate condition to it's trying to look at, good is part of the condition. You have good, you have bad, you have usable, you have excellent. Now, condition, when condition is good, when condition is good, the constant is 3.98, age is minus 0. And so on and so forth. But I will concentrate on the p-value. When the condition is good, what is actually a causative factor to that, which is the significant factor, is accident, maintenance, and usage. All others are not significant. So for good road, good vehicle condition, accident is significant, maintenance is significant, usage is also significant. Then, now let's go to the other one. When the condition is usable, condition of the vehicle becomes usable, that is usable, then what actually influences that is, now let us see which one is significant there. Well, two things are significant here, and those two things are accident and maintenance. So accident and maintenance are significant in this usable condition. Then after this, you now have the post hoc analysis. The post hoc analysis compares what is have to compare, and then it gives us the result. You see here, good to constant, good to age. You can see excellent to, just compare the whole thing the way it's supposed to be. Excellent to constant, excellent to age, excellent to accident, excellent to maintenance, excellent to, they have their relationship, as you can see there. Excellent to user, excellent to engine size, excellent to road con, and excellent to driver. And then you have good, the same way you have usable also. And then why he did not want to talk on the bad is what I don't know. However, that is the results. And then this we're also told that we can find this result also in the value stats folder under the different names. Look at the names of the value stat ordinary logistic results. So let's see if we'll be able to find it there. let's yeah, all the Ordinal Logistic scatter plots, bar chart, or whatnot, but then we are interested in only this for now. Yeah, you can see that is it. Yeah, I brought out the results, and then starting with, of course, the descriptive statistics and so on and so forth, together with all those analyses that he has made. So, is it not a very good and robust package? Thank you, and you can always watch this and this again. Remember how we started, remember what we did, and so on and so forth. So you can see that it's a very, very simple package, simple to use. Just remember the characters you use in saving your data, the characters, the name you use in saving your file, and so on and so forth. Thank you.